Okay, so we're taking a break here, doing some math. So let's look at what we got here. Let's look. Let's kind of rearrange some things here first. That's not what I wanted to do. Okay. It's over here. So once we get what quadrant we're in, we have this kind of wrapping snake pattern that goes this way, then that way, then that way. I think before we kind of figure out those indices, what we should do is we should figure out the XY location of the cell and figure out the normal index location, and then we'll add the transformation to get this wrapping. So right here, this first index value of the snaking pipe, let's not use that right now. That's kind of like an offset. Int lx equals x minus quadrant x times 4, yeah? Int ly, y minus qy times 4. Assert lx greater than or equal to 0, and ly is less than or equal to, and lx is less than or equal to 3, because it's 0, 1, 2, 3. Little down, original global xy to a cell local lx, ly, xy coordinate. Alright, so that's what we're doing here. Okay, so once we have this, want to do index to xy again, or xy to index. And we're going to take lx here, we're going to take ly here, and the width here is, it's a 4x4, and it's the LED span. So did we do LED span anywhere in here yet? No, we didn't do LED span. So LED span and li. Convert lx, ly to its 1D index form using traditional scan line ordering, left to right, then top to bottom. Right, so we're going to reorder that using scanline ordering, and then once we have this here, we're going to say hey, everything is just offset here by this q0. So we need to kind of flip this. So the scanline ordering here is kind of like every other. It's kind of flipped here. So how are we going to do this? So first we got to flip the ordering so that it goes bottom to top. So bottom to top, yeah? And how are we going to get bottom to top like that? I don't know. Because right now we're going this way. We kind of have to invert that. Now, if we just count down instead of up. So right now we're counting up here. If this is 0, 1, 2, 3, 4, 5, 6, we want to count down, right? We want to count down, but then when we get to the other row, we want to invert. So countdown equals, we're going to take the, it should be this 15. Oh, there's where that 15 minus is coming from, right? This 15 minus, it's that inversion here. So 15 minus the index to flip it around, right? Yep. So 16 minus 1 minus Li CD count down. Okay, so this countdown here is, yes, invert our index ordering from counting up to counting down at CD. Yep. So over here we can say, you know, at CD, countdown. At CD, at countdown. And we can go over here and we can do the same thing. We can put this kind of like at CD, at countdown. So that's what that is there. Okay, so after we have this inverted, right? So now we're kind of going 15, 14, 13, 12, 11, 10, 9, 8, 7. We have to modulate and say if it's we need to like divide by 4 somewhere. We got this modulation by 4 and whatnot, so that's probably where we're getting this. One, two, three, 4. So we're going to modulo 4. If we modulo 4, we'll get our groupings, but that's just local. Actually, I want to divide by 4. And this is, divide by 4, this is 0. 1, 0, 1. I want to divide by 4 and then see if it's odd or even. If it's odd or even, we will flip it around, right? So how are we going to do that? So we have this transformation. And we have the index in the correct order now. We can still take the raw index, the original index, if that makes it easier to think about. We can take that original index, that original local index, and say, hey, are you divisible, are you even or odd row, right? Yeah, so what we could do say, you know, if Lx modulus, or Ly modulus 0, modulus 2, so if it's even, so the even things, 0, 1, 0, 1, so the even things are forward. Even row, don't flip this row. Okay. And our FD, int FD, oh god, int FD, flipped, index per depending on odd even row. So we're going to take FD equals CD, else FD equals something minus CD. To figure out how to flip it, though, that's going to depend on what number we're at, right? So, we need to find the y, and we're going to invert the y, multiply it by 4, and then use that to flip. So we're going to take the y. We should have like a... It's not the qx, it's the local y. The local y. Right, we have to flip it. So invert the y. Invert local y-axis, 3 minus Ly. Then multiply by stride 4 to get the so 0 times the stride here, right, for the y, for inverting the y, is 0. For the next row up, we're going to take 1 times the stride of 4. That gives us 4. And the first one is 4 here. It's just flipped, etc., etc. Okay. So invert local y-axis, 3 minus Ly. Then multiply by stride to get the first index. The first index on the left before any left. Is this value to flip? So FD is going to equal this, right? We're going to use that to flip it, right? So depending on if we're odd or even row, odd row, flip this row. So FD should be the final output here. Finally, FD needs to have the appropriate global index offset applied to it. And the global index offset is the Q0, I believe. This Q0? Yeah. So if we look here, we can see we have a Q0 somewhere in here. Lost our spot. Yeah, this Q0 here. So FD plus Q0. And then return the output index. Okay, so if we got all that math correct, then what we're going to see is that John Math is going to be the same as Moga Math. So we're going to take all this, we're going to copy it, and we're going to paste it, and we're just going to see copy this block, but replace Moga Math with John Math. And see if we get the same thing. Okay, let's give that a shot and see what we got. So we're gonna go John Math, and we're not even gonna change any of that. We're just gonna leave it like that. We're gonna give it a shot and see what we got. I'm sure we made some mistakes somewhere. But we gotta include assert if that's what we want to do. So include assert, include printf. So we'll include both of these. And then down where we have the main, we can get rid of stdio.h because we already have that for printf at the top. And let's give that a shot, see what we got, see if we screwed up anywhere. Here, a statement with no effect. So that's just because I don't know what I'm doing. So I go back to my math, we can see FD equals CD. Wrong. Made the mistake here as well. So we got a comment within a comment. Oh, we see this flip this row is wrong. Okay, so what do we got? We have horrible, horrible mistakes here. We got 15, 14, 13, 12, 31. And then this is wrong. 7, 6, 5, 4. This is right. But then we got these negatives here again, right? So it's like we're doing everything. 47, 46, 44, 44. Then 29. So it looks like on some of these, 31, 30, 29. Right, this is right. This is correct. But it's the, these are forward, right? This is forward. This is the evens. And where we need to flip, we're going wrong here. We're going wrong where we need to flip things. So let's look at the things we need to flip. And, this is the value. We're taking this, but this should actually be on the other side, shouldn't it? It should be the CD minus this, maximum. Or well, hold on. So 0, 1, 2, 3. 0, 1, 2, 3. This is going to invert it and multiply it by 4. And then CD, if we want to invert CD, if CD were 0 and we wanted to invert that, then we're going to take this, right? So, do we possibly have, does the Y actually not need to be inverted, maybe? So let's look at this again. We're saying we still don't have the indexes in the inverted order yet, do we? Or actually, CD... somewhere we already inverted the index, right? So we're counting down here. So CD is already counting down. And because of that, the LY, so we already know it's between, we already have an assert for LY, so that's not necessary. Let's give it another run and just inspect it again and see what the heck we're looking at. So, we got this like -3 here. So I think what we got is like, we got 0, 1, 2, 3, 4, 5, 6, 7. Oh, LY. LY should be local. Yeah. Oh, no. We don't want LY, we want... yeah, we want LY. Because the X and Y is the global, so LY. So like 0, 1, 2, 3, right? And then what we're going to do is we're going to say... we're flipping that to say 3, 2, 1, 0. Okay, well, if that's 0, 3 minus 0 was 0 times 4. Seems alright. So if this is 0, if we take CD and minus it, we're going to end up with some problems, aren't we? We're going to end up with some negatives. So if this is 0, if LY is 0 for a second, let's say LY is 0, then 3 minus 0, that's still 3. 3 times 4. 3 times 4 is 12. Okay, let's just say that, we just do FD equals CD really quick. Because I think that if we do that, we're going to see everything kind of, we're not going to see the snaking pattern we're trying to get. And now we see 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So we get that. So what we want to do is we want to invert that, right? So we want to take, I thought it would be LY. 0, 1, 2, 3, right? So LY, but then we're going to flip it. So instead of 0, 1, 2, and 3, We want to invert it, so this is 3, 2, 1, 0. So 3 times, let's say we want to invert this. So 3 times, 3 times 4 is 12, right? 12. Oh, but you know, it's not 12. It's not just 12. We want to invert it. So we want to take the highest thing, right? So the highest thing is going to be 12, 13, 14, 15. So we have to actually add 3, right? So we invert it. We times it by 4. So we could do, to get the highest thing, we flip it, we multiply it by 4. Here, let's break this apart a bit. So 3 times 4, that's going to give us like a 12, but we need 13, 14, 15. 1, 2, 3. We need to add 3. Lowest value of row. So this is lowest value of row. So invert row index times stride to get index. So so we're going to take this, they're going to multiply 4. So this is plus 3 to get highest value of row. Okay. And once we have all this, this is our inversion value. Inverter value. And over here is the value to invert. Okay, so that's ridiculous. That's crazy. But I think that makes sense. So let's give that a shot. See if we made any horrible mistakes or what we got here. Okay, so now let's see. We got 15, 14, 13, 12, 0, 1, 2, 3, 7, 0, 1, 2, 3, 32, 30. So 32, 33, 34, 35, that looks correct. 39, 38, 37, 36. That's correct. 47, 46, 44, that looks correct. But then over in this quadrant, we're not quite correct, are we? Like, this quadrant looks correct. That's correct. 16, 23, So we're close. But, at the top we're not correct. It's like we did it correct for everything else, except for some reason the, this is not correct. 32, 39, 32, 47. So it's correct for this block, but then these top blocks are like, huh, nope. So I don't know what's wrong here. So we're going to assert that CD, we are assuming that CD is in the range of 0 to 15, right? Let's give that a shot. Let's make sure that assert isn't failing, because something isn't quite right. So that's like my first guess. So that's not improper. When we invert the row, I'm gonna guess something about this +3 isn't always true. It's when we add that offset, right? Let's just +0 for a second. Let's +0 instead of this. And kind of see, well, what happens when we +0 like that? So let's +0. Let's get rid of the offset there and see if there's some type of inconsistency or if that offset is doing things. So 0, 7, 0, 15. 0, 7, 0, 15. 0, 7, 0, 15. 0, 7, 0, 15. So there's more than one mistake here, because this is also 0. So before we even worry about this transformation, we should be like, well, what's wrong with here? So before we do this, let's just say FD equals CD again. And just make sure that the values make sense before we apply that wrong thing. Before we apply that transformation, what do we got? So 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 15, 14, 12, 11, 10, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so that all makes sense. So it is this math here, something's wrong with it. Let's look at Ly. So Ly equals the x minus quadrant x times 4. And we're going to invert the row. Multiply by stride. It could be in terms of inverting at the wrong spot, so we might want to do this countdown here. Well, let's keep the countdown. I don't know. Our math is wrong. We got too many transformations piled on top of each other. Or, you know, if we want to flip these values, we have to get their locals first. So we got to invert the row. Times stride to get the index. So int so this lowest value of row is the base index. So bi So bi is the base index. So take that and instead of doing this +3 here, we're just going to do this CD. And we're going to minus the base index. And we should expect some type of thing where the values keep on counting up exactly the same. So on here, 0, 1, 2, 3, 8, 9, 10, 11. So we're off. Zero, 1, 2, 3 is good. But then we got 8, 9, 10, 11. Why is that? So the base index seems to be off by a factor of 8. So this base index that we're using times 4, 1, 2, 3, 4, is incorrect somehow. Zero, 1, 2, 3. So if this is 3, 3 minus 3 is 0. 3 minus 0, 1, 2, 3. This is 2. 3 minus 2 is 1. 0, 1. 3 minus 1 is 2. 0, 1, 2. And then at 0, 3 minus 0 is, well, it's 3. So 3, 2, 1, right? So we have that correct index. This is the correct index here. Then we times 4, so if we're down here, this is times 4. The base index here is 4. Times another 4, 0, 1, 2, so the base index is 8. And the base index here is 12, right? So, times 4 to get that base index. Let's just do FD equals base index for a second. Let's make sure those base indexes make sense. So, FD equals the base index. Make sure the base indexes are actually counting in the direction we think they're counting in. So I think maybe they're not. So the base indexes, so 0 and 8 makes sense. 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, we already have a problem here. There's already another problem. So before we even do this, we gotta do... Before we even do this, we gotta comment this out and make sure that the transformations are correct here. So we have FD here. And FD right now, we're going to set to CD, right? So FD equals CD. And just make sure, hey, are you even correct? Because we have multiple mistakes here compounding on each other, right? Wrong thing. Let's just close this. So 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, right? So that's correct. And then this FD equals CD here and all this craziness. Seems like the LY modulus 2 equals 0 is kind of screwing us up here. So it seems like it's wrecking more values than it should be. So we're just going to say if this is true, like if this is 0, if this is not, if this is the thing that needs to be inverted, we're just going to say, you know, FD equals 0. And we're going to see what that is. We're going to see if our modulus might be wrong. So we got zeros, zeros. Okay, so we got these zeros, 15, 14, 13, 12, 4, 5, 6, 7. 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that does look correct. And then we throw this in here, we're getting some problems. So now when we look at this, 12, 13, 14, 15, 4, 5, 6, 7, that's correct. These are zeros and these are 8s. Those are in the correct spot though. So this base index, we think we can invert it by just taking the current value. Instead of assigning it directly, we think we can just take that current value and we can kind of just be like, bam, like that. And that doesn't look like it's working quite correctly. So remember, the top row is correct and the other things are kind of screwed up here. So 12, 13, 14, 15. 0, 1, 2, 3, 4, 5, 6, 7. That's correct. 0, 1, 2, 3. Okay, so 0, 1, 2, 3, because we added, we inverted it with the base index. And then we have to add the, we have to add that base index back on, right? I think that's all we gotta do. I think we have just to add the base index back on. We just gotta add the base index back on. I think that's all we have to do. Let's check that out. So now 0, 1, 2, 3, 4, 5, 6, 7. So I think we have this correct now. Or did we do our inversion? So we have a different value set. 15, 14, 13, 12. 11, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We're back there. We're back going backwards again, aren't we? So hold on. Let's take a look at that again. So did we not, is it not counting in the wrong direction? We zeroed it out, but I don't think we're counting in the wrong direction. So we're counting down, and this is also counting down. This is also counting down. So we gotta flip it now. So 0 out using base index. And then we're gonna flip it. So 4 minus no, 0 to 3. Flip zeroed out x value. Alright, so let's try that. Let's flip that zeroed out x value, make sure that it's flipped now. Okay. So it's counting up 0, 1, 2, 3. 0, 1, 2, 3, right? Okay. So now, after we flip this, we're going to take this, and we're going to plus undo zeroing out after flipping. Okay. Let's take a look at that. So now, I think we're good. 12, 8, 9, 10, 11, 7, 6, 5, 4, 0, 1, 2, 3, etc. Now these numbers aren't quite right yet, but all we gotta do for these are add the proper offsets, right? So now we just gotta take, let's nuke all of this away. So this Q0, we can just plus Q0 here. And hopefully we can just get rid of the no-op and we'll be good. So now, 15, 14. So Moga's stuff, and my stuff. Okay, so now one last check we can do to make absolutely sure. Assert, make absolutely sure our math matches. Let's say, you know, for px equals 0, px is less than or equal to the 8 minus 1. 8 minus 1, px plus plus. Same thing for y. And we will assert Moga Math px py equals John Math px and py. So we got that visual confirmation, but let's just make sure that, you know, it all works. So let's do that assert, and let's see if we're correct everywhere. Yeah, we're correct. Awesome. So we can also make sure that this assert works, right? We can do like a not equal and be like, hey, let's make absolutely sure that assert works. Okay, cool. So, now, let's just do it like a printf \n. And let's label this stuff. So, printf standard scan line order below. Okay. And this is Moga's remap. So, our new lines should probably be in the opposite order. So let's take where it says Moga's remap, let's put the printf new line down there. And I don't know if this is going to help or if this is just going to... Let's get rid of these. Let's get rid of these for a second. Can't believe I don't know what I'm doing here. Let's do it case by case to kind of get this working. So, standard scanline order below. Okay, this needs... Let's do 2 \n to make it... Alright, let's do 3. And then above mine, let's do 3. And then above this, we'll do 3 as well. Okay, so now let's look at this and see if we have some type of decent... So, Moga's remap, standard scanline order below, Moga's remap, and... yeah. So, let's take this, roll with it, send it off on Facebook, right? So let's run a different browser that isn't blocking Midori. Another browser, Midori, which is not blocking Facebook, so we can show Moga what we got. So right now I have these results. So I'd like to paste them to let's go to Facebook. And I need to put this on www.pastespin.com. We need to go to Pastespin and kind of throw this up there. We'll copy this. We'll call it a Moga Math paste bin. And then we'll show this to him because now we got something for him, right? So let's I have written a test for your code and some ASCII diagrams showing what you are doing. However, I may have not solved it exactly the same way. I couldn't figure out what all of your variables were. As the saying goes, show me your code, and I won't know what you are doing. Show me your data, and I won't need to see your code. So, I could derive what to do from your printout, even though I didn't fully understand what you wrote. Hashtag data. And also, let me see what your other question was. Okay, so you had another question for me. What was the other question? Probably something about the Dectin stuff. Some work on the LED table thing, but then doing rendering engine code. I need to find time to get a provisional patent for some crate designs I made so I can sell my raw acrylic. Etsy to get some profit going. But lately, Victim stuff has been on the back burner. Patent got approved yesterday. This week after being accidentally abandoned because I lost my patent lawyer. So that is cool. But the current patent I need to write, I have to do myself. So I'm trying to scrape together a provisional patent, but I suck at words. Legal use is like trying to program with English, and then your compiler is a lawyer or patent clerk that gets back to you 6 months later. Okay, so anyways, let's take a screenshot of that printout, right? A printout screenshot. Let's take that printout really quick. So we have a printout. Let's go screenshot this printout. Snipping tool. Let's go save this. Let's go to other screen here. File. And then, did we just close? Oh no, here we go. And let's add the picture. Here is screenshot of your mapping tables. First is normal scan line ordering of indexes. Second is your formula. Third is my formula. And there is also a simple unit test in the code that makes sure both of our formula match for the given input set. Okay. So anyways, that was interesting. Let's get off Facebook now and say, let's do some push-ups though, because right now I can see we've probably done a little stream for like maybe an hour. And then earlier, I think we did like an hour-long stream as well. So we should probably do like 20 push-ups, right, to get some stuff done here. So, Moga Math folder. Okay, so yeah, let's do 20 push-ups. So let's look at push-ups here for a second. Push-ups. This is video number 74. We kind of took an intermission here. Yeah, 20 of each, and then we'll keep on going. So, yeah. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Okay, we got 20. We're on this stream, and we're gonna figure out how long our other videos were, figure out a tally, and then we'll be back.